Explicit content. Okay guys, welcome back to Troubleshooting with Wireshark and the command line. Okay y'all, welcome back to another fresh episode of Big Wild Hacking, Troubleshooting Edition. This is the second video in my series on Wireshark, but more importantly, this is going to mainly be about troubleshooting in Windows. So I'm going to diverge for a minute on the subject of troubleshooting with Wireshark into another form of troubleshooting with Windows, which is using the command line to diagnose network issues, and then we'll get back into Wireshark and packet analysis. The first command is going to be the check disk command. The main functions of the check disk command are 1. Error detection. Check disk scans the file system and file system metadata of a volume for logical and physical errors. 2. Error repair. When run with certain parameters like /f, /r, /x, or /b, checkdisk can fix errors it finds on the volume being the drive. 3. Bad sector management. It can identify and mark bad sectors on the disk to prevent future data loss. 4. File system integrity. Check disk verifies the logical integrity of the file system. And the key features of check disk are 1. Disk status display. When run without parameters, check disk displays the status of the current drive. 2. Data recovery. It can recover readable information from bad sectors. 3. Cross-linked file reporting. Check disk reports cross-linked files, though it doesn't automatically fix them. And 4. Offline scanning. For system volumes, check disk can schedule scans for the next system restart. Usage considerations. Check disk is available in all Windows versions and can be run from Command Prompt or PowerShell with administrator privileges. It's recommended to use check disk occasionally on both FAT and NTFS file systems to check for disk errors. The command can take various parameters to customize its operation, such as forcing offline fixes or ignoring previous bad sector records. Running check disk can take anywhere from minutes to hours, depending on factors like disk size and the number of errors. Remember that while check disk is a powerful tool for maintaining disk health, it should be used carefully, especially when applying fixes to active system volumes. Okay guys, let's go into the command prompt. Command prompt. Yeah, I'm gonna run it as administrator. So we're here in the command shell. Now, let's check for errors. We're gonna just run the check disk so it can check for errors. And now I'll press enter. %, 67%. Okay, check disk is running. It'll just take a minute. We're just gonna. Okay, and check disk is done. Let's check it out. Let's see what it says. Okay, let's see. Okay, so there's no bad sectors. The total duration took 44.06 seconds. So this is what happens when you run a check disk without any parameters. So it's just going to scan and gives you a total disk space, how many files, how many indexes, how many are in bad sectors. So there's 0 kilobytes in bad sectors. That's good. Then it has how many kilobytes in use by the system, how many kilobytes occupied by the log file, how many kilobytes available on disk. Now, if I wanted to, I could use the /f or /r command alongside of check disk to fix any known problems, but I don't want to run that and discover a bigger problem and make my computer inoperable because it is my only computer right now. But later in the future, this is good for fixing registry errors and stuff like that on your file disk, on the disk drive. If you don't know what a disk drive is, I'll show you. So if you just go into your files, go down to this PC, the C drive. That is your disk drive. It contains all your files and stuff. like that, all your files. Explicit content. Okay, the next command on our command troubleshooting, network troubleshooting diagnosis is the ping command. The ping command in Windows serves several important purposes. 1. It tests network connectivity. Ping's primary function is to check if a specified network destination, like a website or IP address, is reachable from your computer. 2. Measure response times. It measures the round trip time, the RTT, for messages sent from the source to the destination, indicating network latency. 3. Verify IP addresses or domain name. Ping can be used to confirm that a particular IP address exists and can accept requests. 4. Troubleshoot network issues. It helps diagnose connectivity problems, network congestion, and routing issues. 5. Check host availability. Ping can determine if a specific host or server is operational and responding to network requests. 6. Resolve domain names. When pinging a domain name, it can help resolve the domain to its corresponding IP address. 7. Test DNS resolution. By pinging a domain name, you can verify if your DNS resolution is working correctly. 8. Measure packet loss. Ping reports on any packet loss during the test, which can indicate network reliability issues. 9. Continuous monitoring. Using the TAC-T option, Ping can continuously test a connection, useful for monitoring network stability over time. 10. Network performance testing. By adjusting packet size and frequency, Ping can be used to test network performance under different conditions. To use ping in Windows, you typically open the command prompt and type ping, followed by the IP address or domain name you want to test. The command offers various options to customize its behavior, such as setting the number of echo requests, changing packet size, or specifying the TTL value. Okay, so let's take a look at ping in my command prompt. I'm going to open that up and run it as administrator. So here's my command prompt. And then also, if you type in ping or any command with the slash, also called whack question mark, it will give you a help. It shows you the usage. So when you type in a command space whack question mark or / question mark, it will give you a little help information about the so here's the usage of ping and here's the options of ping. So let's CLS to clear the screen. And now we're going to run ping to google.com. Before I run this command, I just want to verify that I am on my network. So it's perfectly fine that I ping google.com, and this is going to connect. This is going to test the connectivity between my computer and Google's servers. So let's press enter. Okay, the ping scan is done. We got pinging google.com, and here is their IPv6 address. Right there, that's their IPv6 address with 32 bytes of data. So here's the reply. We got 4 replies from Google's IPv6 address. The first one took 34 milliseconds, then 55 milliseconds, another 55 milliseconds, and then 54 milliseconds. So ping and the ping statistics for the ping to the IPv6 Google address. Packets sent, we sent 4 packets, and we received 4 packets, and we lost 0%. And the approximate round trip time in milliseconds was 34 milliseconds for the minimum, and the maximum was 55 milliseconds for an average of 49 milliseconds. And that's the ping command used to test connectivity on a network. Explicit content. Okay, so now we're going to go a little bit deeper into the connectivity issues with network troubleshooting with a command known as tracert. The tracert command or traceroute command in Windows serves several important purposes. 1. Trace network paths. It traces the route that the data packets take from your computer to a specified destination IP address or domain name. 2. Identify network hops. Tracer displays a list of all the routers or hops that data passes through on its way to the destination. 3. Measures latency. It measures and displays the time it takes for data to reach each hop along the path, providing insights into network latency. 4. Troubleshoot connectivity issues. Tracer helps diagnose network problems by identifying where delays or packet losses occur in the connection. 5. Detect routing problems. It can reveal routing loops or inefficient paths in the network. 6. Verify network configuration. Tracer can be used to confirm that routing between networks is working correctly. 7. Determine packet loss. By sending multiple packets to each hop, Tracer can indicate if there's packet loss at a specific point in the network. 8. Resolve IP addresses. It attempts to resolve IP addresses of routers to their domain names, though this can be disabled with the WACD option. 9. Identify network bottlenecks. By comparing response times between hops, you can locate potential bottlenecks in the network. 10. Test reachability. Tracer can help determine if a specific host or server is reachable from your computer. Okay, so let's go into the command line. I'm going to run it as administrator here in the command line. Okay, so we're going to run a tracer to test the connectivity between my computer and Google. Okay, here we go. Okay, it's tracing route to google.com. And then there's the IPv6 address over a maximum of 30 hops. So we got the first two hops, 2 milliseconds, 62 milliseconds. So a hop is every time it reaches a router. Now we're on the third hop, which is taking some time. Okay, looks like the third hop timed out. Okay, the trace is complete. It looks like we had 4 unresolved hops, and the trace is complete. So there is some problems out there with these two hops, this hop, and this hop. So there's a little bit of latency issues going on there, but for the most part, it's good. There was 13 hops to these IPv IPv4 addresses, or no, IPv6. This is the IPv6 address. Yeah, 13 hops. So that's the tracer command. Into it gives you further insight into the connectivity issues. Explicit content. Okay, so now we're going to go even deeper into the connectivity issues when troubleshooting network problems with a command called path ping. The path ping command in Windows has several important purposes. 1. Trace network path. It traces the route that the data packets take from your computer to a specified destination, similar to Tracer. 2. Measures latency and packet loss. PathPing provides detailed information about network latency and packet loss at each hop along the route. 3. Identify problematic network segments. By displaying the degree of packet loss at each router or link, PathPing helps pinpoint which routers or subnets might be causing network issues. 4. Combine ping and tracer functionality. PathPing combines features of both ping and tracer commands, offering more comprehensive network diagnostics. 5. Long-term analysis. Unlike tracer, PathPing sends multiple echo requests over an extended period, providing a more accurate picture of network performance over time. 6. Detailed statistics. It computes and displays statistics based on the packets returned from each router, giving a more in-depth view of network behavior. 7. Troubleshoot network problems. Network administrators use PathPing to diagnose issues like intermittent connectivity problems or slow network performance. Assess route quality. By showing packet loss and latency for each hop, path ping helps evaluate the quality of different network paths. 9. Verify network configuration. It can be used to confirm that routing between networks is functioning correctly. 10. Detect routing inefficiencies. Path ping can reveal routing loops or inefficient paths in the network. Okay, so let's take a look at path ping. I'm going to open my command line, run it as administrator, and here is the command line. Let's do path ping to Google. Okay, here we go. Tracing route to google.com. Here's Google's IPv6 address, and here's my IPv6 address, Brian's comp. That's Brian's computer. Yep. Wow, this third hop sure is taking a long time. Thank God they're only going up to 30, maximum of 30 hops. We got Google's IPv6 address right there. Got my computer, and then here's two IPv6 routers. And the third hop has been quite some time. Okay, yeah, so I just aborted the path ping because it was taking a ridiculously long time. I'm not going to waste any more time going through path ping because we went over ping and tracer, and path ping is basically ping and tracer combined. So it's really okay that we just skip that one. That's okay. As long as you do tracer and ping, you don't really need to do a path ping. Explicit content. Okay, there are several other commands that can be used to diagnose and resolve network problems in Windows, and I will go over and discuss those further in later episodes within the troubleshooting series. So stay tuned, guys, so we can get back into some packet analysis with Wireshark. Explicit content.